Let us consider example number 1. We're going to express each equation in general form. Now, for reference, I just rewrote. This is the general form where ax plus by plus c are all to one side of the equation is equal to 0. An additional, we have to consider these two conditions. A is positive, and a, b, and c are integer numbers. Reminder that integer numbers in teenage language would be positive or negative whole numbers, but a little bit more than that. All right, first thing that I'm going to do is to change it is I'm going to force one side to be equal to 0. I take a look at this right-hand side, and I could think that what I'm going to do is I'm going to add 3x to both sides, and that would take care of that minus 3x. And I would add 5 to both sides. Allow me to do that over again. I'm going to rewrite my equation. Y is equal to negative 3x minus 5. So what I would like to do is I would like to cancel this negative 3x. I do that by adding 3x to this side, and I add 3x to this side. Now I would like to cancel out the subtract 5, so I'm going to add 5 to this side, and I'm going to add 5 to this side. Now, what is intended on the right-hand side? Well, this negative 3x and positive 3x cancel out. Negative 5 plus 5 cancel each other out. And what we're left with is 0. Now, I'm going to write this as 3x plus y plus 5. And that would be this equation in general form. I have a, b, c are all integer values. And the additional requirement that a is positive is also met, because here a is 3. Coefficient in front of the x. So I'm just going to take another look at that. And really, I'm going to use a more friendly, algebra-friendly way to do this. If I have this equation, y is equal to negative 3x plus 5. And what I can do is y, if I add 3x to both sides, I know that this is canceled out. And if I add 5 to both sides, so I have to add 3x to both sides. And if I add 5 to both sides, this term is canceled out. And I get 0. So 3x plus y plus 5 is equal to 0, and it's done. I know most of you guys would say, well, I'm going to move it over to the other side and it becomes the opposite, but think of it as an inverse operation. It is the undoing. All right, great question here. Now, remember, sometimes it's better to be really clever in math. Path 1. What am I going to do? Path 1, I'm going to maybe pack up everything and move it over to the left-hand side. So I'm going to equate the right-hand side is equal to 0. So I ask myself, how do I get rid of that 2x? Well, I would have to subtract 2x to this side. How would I get rid of this positive 3? Well, I would subtract 3 to both sides. So I get the equation negative 2x plus y minus 3 is equal to 0. Now notice what I did, it's x, y, constant. That's the way general form is written. So my a value is negative 2, my b value is 1, and my c value is negative 3. But keep in mind that a, b, and c have to be integer values. We have that. But a has to be positive. So I ask myself, how can I change a to be positive? And I can change a to be positive simply by multiplying both sides by negative 1. So I take this side, and I multiply it by -1, and I multiply the right-hand side by -1. And I now know that 0 times -1, anything times 0 is 0. And then I'm multiplying a constant into a trinomial. -1 times -2x is 2x. -1 times y is -y. -1 times -3 is +3. So that's the general form. So that was the first go of things. I'm going to do it maybe in a different way. I'm going to try to be more clever. I know this to be true. A, B, and C have to be integers. And if I look, the thing in front of the x is an integer, the coefficient in front of the y is an integer, and my constant is an integer. So we're looking good. We're sitting pretty here. But A has to be positive. Well, wait a second. If I notice, A is already positive, right? So this is great. So if I move it over to the other side, it would turn negative. I don't want to do that. Wouldn't it just be easier to pack up this and move it over? So let's do that. So it's just thinking ahead a little bit. So this is really 2x plus 3. So y. So I'm just going to subtract y to this side, and subtract y to this side. And what I get is 0 is equal to 2x minus y plus 3. And believe it or not, that is standard form. One side is equal to 0. You may not like this, so you can just rewrite it. Like this. If A is equal to B, right? If you have some A, a quantity that is equal to B, then this means that B is equal to A. So you can just switch the sides, and you don't need to change the negatives to positives, because it's a simple expression. All right. Hopefully, oh, great. This is going to be more challenging to us. Okay, let's keep in mind what we're doing. A, B, C have to be integers. A has to be positive. And we're trying to write something that looks like, are we okay? I know what you're thinking. That is not an integer. I agree. So keep in mind that we're dealing with an equation. So let's make, I think, first step is let's get coefficients A, B, and C to be integers. Which step is first? It doesn't matter as long equations are incredibly robust. You can bend them and shape them how you want as long as they conform to math. So here's what I'm going to do. I'm just going to simply rewrite my equation, and I'm going to ask myself, I wish there was a quantity that I could multiply this coefficient so that it is an integer. And in fact, what I'm going to do is I'm going to multiply it by 3. I'm going to multiply this side by 3. Really, if you want to write this down, you multiply by the lowest common denominator. And now it doesn't even need to be the lowest common denominator, but the lowest common denominator makes math beautiful and easy. Two things that I love. So the lowest common denominator in this was 3, so I just chose to multiply by 3. Now I multiplied both sides by 3 because I need to maintain equality. Now 3 times y is 3y. Now remember from last year, when you have a constant multiplying, this is a binomial and this is my 3 is a constant, your constant needs to multiply both terms of your binomial. So 2 over 3x times 3 minus 4 times 3. Now, this is going to be 3y. Now, 2 over 3x times 3 will just simply be 2x. Minus 4 times 3 is minus 12. So there we have it. I'm going to come back to this multiplication because I know it's likely some of you guys are wondering about that. Anyways, I'm almost home. If you notice, I wish to have ax plus by plus c is equal to 0. A has to be positive. Well, a is positive over here, so if I move 3y over to the other side, and I do that by subtracting 3y to the right-hand side. So there's my equation. You move this over here, you would say, and it becomes the opposite, negative 3y. So this is it in standard form. So you could write it like this, or some people like to see it like this. All right, as promised, I'm just going to talk about this. So I'm only going to concentrate on this multiplication, 2 over 3x times 3. Now, somehow magically, I pulled it out of thin air that I was multiplying by 3, and really you have to look for your lowest common denominator. If this kind of thing trips you up, simply just do this. So 2 over 3x times 3 over 1. It's 3. And what you see is that we have a common factor in the numerator and the denominator, or 3. So it just becomes 2 times x divided by 1, which is 2x. All right. Last but not least, the toughest one of all. Y is equal to negative 5 over 2x plus 7. Now, I keep on going back and saying, well, it has to have the form ax plus by plus c is equal to 0. A, b, and c have to be integer numbers, and a has to be positive. Which one do you do first? It doesn't matter. But what I'm going to do first is I'm going to make sure that I don't have to deal with fractions. So in other words, I'm going to change a, b, and c to be integers. So if I do this, what am I going to multiply both sides by? Well, my LCD is equal to 2. So I'm going to multiply both sides by 2. So 2 times y, so the left-hand side, y times 2 is 2y. The right-hand side is a little bit more tricky, so I just simply slow down my thought process. There we have it. Times 2. So recognize that the right-hand side is a binomial, or it has 2 parts. So what you have to do is you have to multiply both terms in your binomial by 2. So the left-hand side stays as y, and now we have negative 5 over 2x plus 7, and then I had to multiply those 2 terms by 2 times 2. And what I get is 2y is equal to 5 over 2x times 2 is negative 5, because factor of 2, both top and bottom cancel each other out, plus 14. Okay, I am going to introduce a weird idea that sometimes saves you tons of time. So what I'm going to do is I'm going to subtract 2y to both sides. So in other words, I'm forcing everything over to one side, and this is ugly looking. So it is written in this form. A, b, and c are integers, but what I've noticed is that my coefficient for a, the thing in front of the x, is negative. What I'm going to do, and in the teenage brain, people say, well, all you're doing is switching your signs. Okay, but I'm going to multiply both sides by negative 1. And if I do that, I take a look at my left-hand side, -1 times 0 is just 0, because anything times 0 is 0. So now what I'm going to do is I have to distribute the multiplication of that -1 to each of the term. So -1 times -5x simply is 5x. -1 times -2y is positive 2y. -1 times 4, subtract 4. Believe it or not, now I have all the conditions met. So you may not like the way it looks, so you may want to write it where the right-hand side is equal to 0. And there we have it.